So in this video, we're going to pick up where we left off last with molar mass and Avogadro's number, and we're going to talk about how we go from atoms to grams or from grams to atoms. So here's a simple diagram that will help us remember what the calculations are to go between atoms, moles, and grams. So we've already covered that to go from atoms to moles or vice versa, we're either going to multiply or divide by Avogadro's number. If we're going from atoms to moles, we're going to divide by Avogadro's number. If we go from moles to atoms or molecules, we multiply by Avogadro's number. To go from moles to grams, I'm going to multiply using the atomic or molar mass of the substance. And to go from grams to moles, I'm going to divide by the molar mass. So if I'm going to go from atoms to grams, I would need to divide by Avogadro's number and then multiply by the molar mass. To go from grams to atoms, I would need to divide by the molar mass first and then multiply by Avogadro's number. So here's an example. Let's say I want to know how many atoms are in 5.4 grams of gold. We know that 1 mole of gold, according to the periodic table, would have a mass of 196.967 grams. That's its atomic mass. And we know that 1 mole of anything is Avogadro's number of atoms. So to find the number of atoms in 5.4 grams of gold, first, I would take the 5.4 grams of gold and divide by the molar mass of gold to get moles. So if I take 5.4 and divide it by 196.967, I get 0.027 moles of gold. Then I would take that moles and I would multiply by Avogadro's number to get atoms. So 0.027 times Avogadro's number is 1.63 times 10 to the 22 atoms of gold. See if you can find how many atoms of aluminum are in 2.75 moles of aluminum. Pause the video, use your calculator, and see if you can come up with the answer. So we know that 1 mole is 6.02 times 10 to the 23rd atoms. So if I take 2.75 moles and multiply it by 6.02 times 10 to the 23, I get 1.66 times 10 to the 24 atoms. Here's another one. Let's say I want to know the mass in grams of 1.20 times 10 to the 8 atoms of copper. Well, 1 mole is 6.02 times 10 to the 23rd atoms. And we know that 1 mole of copper is 63.55 grams according to the periodic table. So to find the mass, I would first divide the atoms given by the Avogadro's number, and then I would multiply the result by the molar mass of copper to get the grams. So 1.20 times 10 to the 8th divided by 6.02 times 10 to the 23rd is 1.99 times 10 to the negative 16 moles of copper. If I take that result and multiply it by 63.55, I would find that I would have 1.27 times 10 to the negative 14 grams of copper, which is, yes, an impossible amount to see, but we're working with the theoreticals right now. You try one. See if you can find the mass in grams of 7.5 times 10 to the 15 atoms of nickel. So we know that 1 mole is 6.02 times 10 to the 23 atoms. And we know that 1 mole of nickel, according to the periodic table, is 58.693 grams. So I would divide the atoms given by 6.02 times 10 to the 23 to get moles, which is 1.2 times 10 to the negative 8 moles of nickel. Then I would take that moles and multiply it by the molar mass of nickel, 58.693 grams, to get 7.3 times 10 to the negative 7 grams of nickel. Next time we will talk about percent composition of compounds.